To get from point A to point B, you must avoid walking through a pond. To avoid the pond, you must walk 34 meters south and 41 meters east. To the nearest meter, how many meters would be saved if it were possible to walk through the pond? Interesting. Okay. Let's draw a picture of what they're describing. 34 meters south, 41 meters east. Well, I'm going to do a normal direction kind of thing here. And I'm going to use, this is north, south, east, and west. You know the compass directions, north, south, east, and west. So then I'm going to start us up here. He's going to be start. And we're going to go 34 meters south. Okay. So a chunk south. And then, right, so we walked south. Walked south, started and walked south. And then even longer east. So that'll be to the right. Whoops. Tool back on. Like that. That'll be to the east. And this is, so this is actually point B. So this is, we start here at point A, we end at point B. We're walking from point A to point B, right? And the reason is because, why are we doing all this crazy walking? Because there's this pond. Get the idea? So to get from A to B, you can't go straight through the pond. Can't walk on water there. So they're asking, to the nearest meter, how many meters would be saved if it were possible to walk through the pond? So in other words, if we could walk directly like that, how far would that be? And how many meters would we save? So in other words, this is 34 meters south. This is 41 meters east. What is this direction X? Like, what would that be? And how many would we save? That's the crucial question. How many would be saved? We'll try to figure that out in the end. So is that making sense? So first off, we've got to find X, don't we? Because that's what we're saying. They're saying, if it were possible to walk through the pond, if you could walk on water, you could walk right through the pond. How long would that be for some? How can we find that X there? Well, I think you probably know what we're going to do, because we have a right angle right here, right? Because when you go perfectly south, right, perfectly south and then perfectly east, those are at 90 degrees to each other, right? We went south, then we went east. So, which means we have a right triangle, don't we? So, you know the drill. For any right triangle. What do we do for any right triangle? A squared plus B squared is C squared. A squared plus B squared is C squared for any right triangle. Now, the crucial question is, which one is C? Which one is C? Whenever you use this formula called the Pythagorean theorem, A squared plus B squared is C squared, you've got to identify which one is C. A and B doesn't really matter. They're interchangeable, but C is important. It's important to get C correct. How do we know which one C is? C is always the longest side. This is C over here, which we're calling X. So that is C. Excuse me, we're calling it X. And there's our wall of separation. Is that making sense what I just did there? The side across from the right angle is the longest side, right? In the formula, A squared plus B squared, they add up to equal C squared. So C squared's got to be the biggest. So c squared is the biggest. So it's the biggest side. So this side is the biggest side. It's the side across from the right angle. It's the biggest side in the triangle. So it's the c in the formula. And it's what we call x. Or you can just call it c. I mean, you don't need to, if you want to just call it c, let's just do that. Let's just call it c. Whatever. Call it Joe. You know, it's just all a name. It doesn't matter. Call it Joe or Maria or whatever. It's just a name. We're trying to find it. Okay. Now the other two sides are 34 and 41. You can put them in either order. You can put the 41 first and then the 34. It doesn't matter. The A and B are interchangeable. Doesn't matter at all. Okay, and squared means times itself, right? 34 times 34. 41 times 41. And then hit the buttons on our calculator here. You can use the square button, the power button if you want. Or just multiply 34 times 34. And I'm getting like that. And then add those together. I'm getting 37. Okay, now how do I finish solving for C here? I've got to do the square root on both sides, don't I? Square root and square root, because that's what gets rid of the 2 power. Right? That cancels out the 2 power. So we got C alone. And whatever you do to one side, you have no choice but to do the same thing to the other. Got to square root both sides. And I'm getting 53.26334. Okay. Now, also, they didn't say how many decimal places. Oh, yeah, they did. They said nearest meter. That's right. Right here. Nearest meter. So they want a whole meter. So I'm going to round that. I'm going to cut it right here. This 2 means leave it alone. So 53. So I'm rounding C to the nearest whole meter. C is 53. So this C, let me come over here, is 53, rounded to the nearest whole meter, right? 53.2, which rounds closer to 53 than it does to 54. But anyway, now we're not done. That's not the answer. Careful, careful, careful. It's temptation to say, boom, there's my answer. Type it in. We got it. We're done. No, not quite so fast. Let's be a little more careful. So we have got the 53 answer, but that they didn't ask how long would the trip be straight over the pond if you could walk on water. They said if you could walk on water, how many meters would be saved if you could walk through the pond? How many would be saved? Oh. How many would be saved if we could walk straight through the pond? That's what they're saying. Let me just rewrite it here for clarity. How many meters would be saved if we could walk straight through the pond? Well, going down and over equals 34 plus 41, right? We go 34 down and 41 over. We go from A to B by going 31 down, 41 over. Add those up. What is that? 75? 75. Straight through the pond is 53. You tracking with me? If you go straight through the pond, that's 53. If you go down and over, that's 34 plus 41, that's 75. So if we could go straight through the pond, what would we say? So straight would say, straight would save 75 minus 53, which is, what's that, 22? Straight would save 22 meters. 22, and you want to choose meters here, because this is what we're talking about. 22 meters would have been saved. 22 meters would have been saved on that. And so that's a tricky problem. There we go.